Hello everyone. As part of learning generative AI, in the previous session we have seen the introductory concepts. Now we shall see uh, what are the key features of large language models. Generative AI majorly works under the category of large language models. So let us see the key characteristics of or key features of large language models. So whenever you are talking about large language models, let us have a brief introduction of what large language models are. So the large language models, they are the foundation models which are trained on vast amounts of data sets, wherein they are trying to understand an existing language and they are trying to generate new content in the same language or other language. And they are also trying to work on deep learning architectures, and most of the time they work on neural networks which are also called as transformers. And because they are trained on huge amounts of data, they can understand the intricacies of the languages, the context of the language, and nested clauses that are existing in the language, and they can also talk about narrative generation of a language, summarize the text. They can do various possible tasks. And large language models, they are representing a significant advancement in the field of natural language processing with the ability to generate, understand and manipulate human language. And they are built on deep learning architectures. Particularly they use the transformer model. We will see what exactly the transformer model is. LLMs have opened new possibilities in the field of artificial intelligence or AI driven application domains. Let us talk about the session topic for today, key features of LLMs. Large language models have several key characteristics. We are going to discuss some of them, and they are the most, these key features are making it the powerful tool for natural language processing tasks. And one of the characteristics to start with is scale. When you talk about scale, we generally talk about the size of a particular parameter. So when you talk about scale, first one is what is the size of the parameters. Large language models, as it was kept on mentioning, they are trained on vast amounts of data sets, huge amounts of data sets, wherein the number of parameters will be considerably very high. Sometimes it ranges in the billions. There are number of parameters in a data set whose number is in the range of billions. Can you imagine a machine learning task wherein the data set was limited to a maximum of 15, 20 or at the maximum 50 parameters, whereas you are trying to work with a large language model which is trying to understand one complete language, or it is trying to understand more number of languages wherein it is doing various tasks. So in this process of working with various languages and natural language processing, the number of parameters it is working with is in the ranges of billions. So size of parameters is one of the key characteristics of LLMs. Then training data. When you are trying to talk about LLMs, because they are trained on huge amounts of data sets, vast amounts of data sets, what is happening is it is trying to understand the internal features of the languages, the complexities of the languages at a large scale. Then coming to pre-training and fine-tuning. Again, these are the key features of LLMs. What is pre-training? When you are trying to work with large language models, pre-training consists of unsupervised learning, wherein you are subjecting the model to get trained with a huge amount of language data set. And this process happens under unsupervised learning, wherein it is trying to understand the language features first. Once we finish pre-training, we go to the next phase or the next feature called as fine-tuning. What is fine-tuning? Once under pre-training it has understood the language, now the fine-tuning task takes place wherein you are subjecting the model to supervised learning and it has to perform a specific task. Now previously under pre-training it was given the chance of understanding the complete language. Once we understand, once the model understands the language, what are you doing in fine tuning? Under supervised learning method, you are making the model perform a specific task. Say for example, I understood a language. After understanding, you asked me, can you summarize this paragraph? You give me a transcript and you asked me, because you know this particular language, say for example Telugu, you gave me a transcript in Telugu because you know the language, can you summarize this one? So you are trying to, first under pre-training you allowed me to learn the language Telugu, then under fine tuning you are giving me a transcript which is written in Telugu and you are trying to ask me, can you summarize this? That is fine tuning. So fine tuning happens under supervised learning method and pre-training happens under unsupervised learning method. So this is the second key feature of LLM. Then the third one, very important one, LLM works on transformer architecture. What do you mean by transformer architecture? Whenever you are trying to allow the LLM to work under transformer architecture, it has a very good mechanism called as self-attention. What do we mean by self-attention? This self-attention, what happens is the self-attention mechanism focuses on understanding different parts of the language and it also helps to understand various contexts of the language. So from when you are generating the input, you are trying to talk about the output also. So the model can understand both the inputs of the language processing as well as the outputs of the processing the language where it is trying to get trained. Then coming to the next one, layer stacking. This comes with multiple layers. The transformer architecture comes with multiple layers of supervised learning and multiple layers of transformers wherein it is also coming with neural networks feed forward mechanism and it is trying to understand various levels of abstraction of the language. So when you are talking about self-attention mechanism, you are allowing it to understand both the inputs and outputs and the complexities of the language, the context of the language, everything. Under layer stacking, you are making sure the model is getting trained on the levels of abstraction of a language. Say for example, you are trying to, again I take example of language Telugu. If I speak this sentence, what could be the response from the other person? Can we predict this one? To an extent, because if I ask what is your name in Telugu, you can respond. I know what would be the response from the other person. You can predict. So the model is trying to understand what is the input pattern and what would be the output pattern. That is happening under self-attention mechanism. Under layer stacking, I am not only trying to understand how do I ask a question, instead I am also trying to see instead of name, if they used a synonym of name in Telugu, can I understand that or not? What are various levels of abstraction the language is having? Can I understand that or not? That will be taken care by layer stacking. Next, contextual understanding. This is another feature of large language models. Under contextual understanding, we talk about contextual embeddings and long range dependencies. What is contextual embeddings? When I speak something, I should know a particular word is having a meaning and a particular word might have multiple meanings depending on the context. So, you are trying to make sure in which context the word is used. As a human being, we can try to understand from the context. Now you are making sure the LLM is also trying to understand a particular word used in which context, right? So say for example, I might say uh, a particular word, I have an apple, right? So what is the context now? Is say for example it's lunchtime in your office or in your college. Suppose I say I have brought an apple. So apple could be your the fruit, or apple could be a device manufactured by a specific company. So what is the context now? You are talking about apple when it is lunchtime. So people might think you are talking about a fruit, right? So that is human understanding depending on the context. Now you are making sure your LLM is also trying to take care of contextual embeddings of words, right? Then long range dependencies. This long range dependencies, they will try to understand the intricacies of the languages, and they will try to understand nested clauses, and they will also go for narrations, long narrations of a language, and they are able to understand those things also. So when you are talking about a specific word with multiple meanings, you are making sure LLM is trying to understand the context in which the word is used. At the same time, when I am talking about nested clauses, I keep on joining them using conjunctions. If I do this and I do that and I do this and I do that, I am trying to join multiple clauses. So you are making sure your LLM is trying to understand those nested clauses, and it is also trying to understand long narrations. What is zero shot, few shot, and transfer learning? This is another key feature of LLM. What do I mean by, first of all, transfer learning? What is transfer learning? Already I have worked with an LLM and I have done the pre-training of that, and I have gained some knowledge during the pre-training. The knowledge gained or the learning gained during pre-training of a model for a particular task can be used for working with another task with slight adjustments. That is called as transfer learning. While doing a particular task, I learned something, and when I am working with another task, I am trying to use the same kind of learning. So this is called as transfer learning. While doing that, you have two options, zero shot or few shot. What do I mean by this? Say for example, as I take the previous example, I learned the language Telugu, right? Now you are asking me, can you give me meaning of this particular paragraph which is written in English? Can you give me a meaning of this particular paragraph in Telugu? So what are you trying to do there? You allowed me to learn the complete language. You are asking me to do a specific task of translation. Do I need to again get trained, or can I directly do that? If you can do that directly, if the model can do it directly without any specific training for this particular translation job, we say the LLM is working with zero shot learning. Or if the model needs to have a few steps of training, we say it is working with few shot learning. And as I told, one more feature under the same, transfer learning. So what is transfer learning? Whatever I have learned during pre-training, can this knowledge be used while the same LLM is working with another task? If yes, yes, the LLM is working with transfer learning. Apart from that, emergent abilities, creativity, and problem solving. So the LLM not only is learning particular thing, it is able to generate new content. It can generate images, it can generate audio, it can generate video, whatever you are trying to talk about, it is trying to creatively work on generating new content. Not only that, it is trying to solve the problems of multiple questions. What are multiple questions? You can ask for summarization, you can ask for translation, you can ask for explanation, various tasks. So it is trying to help you to solve various issues. Not only that, it is also having the capabilities of multimodal. What do you mean by multimodal? It can work with multiple modalities of the data. It can work with text information, it can work with images, videos, graphics, whatnot. So, if the LLM is capable of working with multiple types of data, we say it is multimodal capable LLM. Ethical and societal considerations, this is of little bit of consideration wherein bias and fairness. Sometimes once the LLM learns the language, there are situations wherein it might go into biased nature of learning the language, and it may not give you a fair output for any question or for any task. It may not give you a fair output, which might lead into some complexities, complex issues. In such cases, what should be done? This is still under research. If the LLM is subjected to bias and the fairness is slightly missing and you are not getting the proper output, but it is leading you into some problematic situations. How do we deal with such LLMs? It's still under research. Resource intensity, LLM is working fine with huge amounts of data, but you need to take care of storing that huge amounts of data, the processing capabilities, all these things, we call it as resource intensity. Interpretability, what do you mean by that? Interpretability, LLM is trying to solve all the works, but what algorithm it is using, how it is arriving at a conclusion, how it is arriving at an output, those things cannot be predicted. So, it is interpretability is also an issue. So, put into summary, these are the characteristics which are collectively making the LLMs highly efficient. Leaving one or two issues, LLMs are working fine so far. So, these are the key characteristics which we need to see whenever you are trying to understand LLMs. Thank you.